Alrighty there, how's it going? Today we're going to talk about valence electrons and what they are. Also, we're going to talk about how to determine the number of valence electrons in any atom. So let's get to it. I'm going to switch over to presentation mode so we can start really digging into what valence electrons are. Alrighty, so bear with me. All right, you should now see my whiteboard. And again, we're talking about valence electrons. So let me write it down. And again, a while ago, we talked about what valence electrons are. So let's refresh. Valence electrons are those electrons furthest away from the center of an atom or furthest away from the nucleus. That is, how many electrons are there in that one last energy level? There are two ways to determine that number of valence electrons. So the long method, that's what we're going to do first, is basically sketching the Bohr model and then really looking at the very last energy level to figure out how many dots are there. In addition, there is a very short method of how to do it, but we're not going to do that yet. We're going to do it after we do the long way. Okay, so here we go. For example, in your question number 2, you're asked to determine the number of valence electrons for potassium. So potassium is the letter K. And we need some information in order to be able to sketch the Bohr model for potassium. We need to know the number of protons, the number of neutrons, and the number of electrons. And for funsies, we're going to add the number of valence electrons, which is our ultimate goal. I'm going to write it down on the right side, just for funsies. Number of valence electrons. And we'll write it down right here once we find out, just for funsies. Okay, so let's look at a periodic table to determine the numbers that we need in order to be able to sketch that Bohr model. So potassium is right here. We need to figure out, well, we need to know the atomic number and the atomic mass. So we have 19 and 39.098. So 39.098 and a 19 as the atomic number. Okay, we need to write those numbers so that we remember that the 19, the atomic number, is the number of protons. It is also the number of electrons in a neutral atom, which is a neutral atom. We're not talking about ions. Okay, and the number of neutrons is basically the atomic mass minus the atomic number, but we have to round. So 39.09 rounds to 39.0. 39.0 minus a 19, that makes it 20. So we have 20 neutrons. Now we can start sketching the Bohr model so we can look at that one last layer or energy level and figure out the number of valence electrons in that outer shell. Okay, so in the center, nucleus, we have the 20, that's a 20 neutrons, and we have 19 protons. Our first energy level, let's remember, it can only hold as many as 2 valence electrons. We'll sketch our next energy level. The next one can hold as many as 8 valence electrons. So far we got 10. We have to do a total of 19. This one fits 8 as well. And so far, if I count, I have a total of 18 electrons, but I need 19. So I need to sketch that one layer, which also fits 8. But if we already have 18 and we need a total of 19, we only need to sketch 1 electron. Okay? That's my last electron. And I made it blue just for fun. You don't have to do it that way. And again, let's go back to determining the number of valence electrons. And again, by definition, it is the number of electrons on the outermost energy level, or the furthest away from the nucleus. So in other words, this energy level is the energy level we need to look at to find out the number of those electrons, which is just 1. Whew, that was difficult. Yeah, so all it is you have to sketch the entire Bohr model in order to find that out. Yeah. That's no fun. But anyway, that being said, another question in your assignment, let me read it to you, says, that you need to think back to the periodic table of Bohr models. How many valence electrons does each element in group 1 have? Okay, I know, because I've looked at the periodic table, that potassium is part of group 1. So let's look at the periodic table of Bohr models and remember. In fact, let's look at a regular periodic table. Let's see if I can find it real quick. Okay, so this is the periodic table. This is group 1. So potassium has 1 valence electron. And let's see what Na, lithium, and hydrogen have. Let's look at that Bohr model, or periodic table of Bohr models. This is all group 1 right here. Let me go ahead and draw real quick. Let's choose this one. This is group 1. And then this is group 18, because this is a small version of the periodic table. A while ago, I cropped it. 18, 17, 16, 15, 14, 13, and this is group 2. Okay, so all elements in group 1, notice that they have 1 valence electron, only 1 on the outermost, only 1, and there's nothing else. So everything right here will have only 1 valence electron. You will need to go back and open this assignment. It's called the periodic table of Bohr models in Canvas. And you will notice that there's another pattern that arises for group 2. Same for group 13, same for group 14. Look at those patterns and see if you can answer those questions. Okay, so in short, the long method of determining the number of valence electrons is sketching the whole Bohr model and looking at that one last energy level. The short method is by looking at the Roman numerals that appear on the periodic table. Ooh, what's that, Mr. Barajas? Well, let's go ahead and talk about those. Let me delete everything from this page. There are 10 well, actually, there are a few Roman numerals in the periodic table, but there's 10 that are important, the 1 through 10 Roman numerals. So if you don't know it yet, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We're going to sketch, or we're going to write down those numbers in their Roman numerals, or according to the respective Roman numerals. 1 is I, 2 is II, 3 is III, 4 is IV, 5 is V, 6 is VI, 7 is VII, 8 is VIII, 9 is IX, and 10 is just simply X. Why do we care? Well, look at this. Look at these numbers, 1 through 10. 1, 2, 3, 4, 5, all the way through 10. If you look at the periodic table, the one that you have, the colored periodic table or the printable periodic table that you have in Canvas, they all have the Roman numerals. Ooh, let's go back. Let's see. Okay. Well, this one doesn't have it, but we can always write it in. There should be a, well, on this one, let me turn it to black. There it is. This guy, there should be an I. Right here, you see a double I, that's 2. Right there, before the A, you see 3. You see an IV, that's a 4. You see a V, you see a VI, you see a VII, and then the last one, it's in VI. Oh, it doesn't show it either, but this one should be a VIII for 8, okay? That's the number of valence electrons in any of the atoms all the way down in this family, 2 all the way down this family. I'm going to skip a few. This number, 8, all the way down this family, with the exception of this one, but we'll talk about that one later. 7, all the way down this family, so on and so forth. That's really easy. So, Mr. Barajas, let's say, so if you wanted us to determine the number of valence electrons, let's say in oxygen. Okay, I'll look in the periodic table for the symbol O, and that would be in family. Let's find out the periodic table where it is. Oh, okay. So let me go ahead and clean this one up a little. VI. What does VI stand for? Erase the A. Don't worry about the A. VI stands for 6. Let's see. Is that true? VI 6. That means that oxygen has 6 valence electrons. And if we were to sketch the Bohr model for that one, the very last shell should only have 1, 2, 3, 4, 5, 6 valence electrons. The very last shell. And every other shell, everything inside should be full. Yeah. So that is how we determine the number of valence electrons the short way, just by looking at the periodic table and looking at those Roman numerals. Those guys right there. That's one on the right. There you go. The long method, again, it's sketching the Bohr model. So whichever method works for you, go ahead and use it. If you want to sketch the Bohr models for funsies, be my guest. But anyway, the point is, there you go. That's how we figure out how many valence electrons there are in any given atom. If you want to rewatch this video because you're confused, please do so. If you need to, even better, do so again. So watch this video over and over until you figure out how those valence electrons are determined given the two methods. If you get stuck, feel free to send me an email, send me a message, phone call, or whatever, as long as you let me know so that we can help you finish up the first section of that handout. Alrighty, that being said, you guys have a wonderful day, and don't forget to watch the next video.